This line introduces the topic of using scikit-learn's "clone" function to create copies of machine learning models. We'll be exploring how this function works and what to expect when using it. The focus is on understanding the implications of using clone for creating independent copies. This line introduces the topic of using scikit-learn's "clone" function to create copies of machine learning models. We'll be exploring how this function works and what to expect when using it. The focus is on understanding the implications of using clone for creating independent copies. This line poses the core question of the quiz. We'll need to carefully evaluate several statements about the behavior of Sklearn, base, clone to determine which ones are correct. Pay close attention to the details in each statement. This line poses the core question of the quiz. We'll need to carefully evaluate several statements about the behavior of Sklearn, base, clone to determine which ones are correct. Pay close attention to the details in each statement. Statement A claims that Sklearn, base, clone always makes a deep copy, resulting in total independence between the original model and its clone. We'll need to examine if this is always true, particularly when dealing with complex data structures. Statement A claims that Sklearn, base, clone always makes a deep copy, resulting in total independence between the original model and its clone. We'll need to examine if this is always true, particularly when dealing with complex data structures. Statement B asserts that changes to a clone created with Sklearn, base, clone won't impact the original model. This statement explores the central goal of cloning, creating independent copies. This is a key point to consider. Statement B asserts that changes to a clone created with Sklearn, base, clone won't impact the original model. This statement explores the central goal of cloning, creating independent copies. This is a key point to consider. Statement C restricts the functionality of Sklearn, base, clone to only those estimators having a fit method. We need to verify the scope of Sklearn, base, clone and see if this limitation holds true. Statement C restricts the functionality of Sklearn, base, clone to only those estimators having a fit method. We need to verify the scope of Sklearn, base, clone and see if this limitation holds true. Statement D addresses the behavior of Sklearn, base, clone when dealing with mutable objects, like lists or dictionaries, within the model. This is where the deep copy aspect becomes really important. Understanding the implications of mutability is critical in this statement. Statement D addresses the behavior of Sklearn, base, clone when dealing with mutable objects, like lists or dictionaries, within the model. This is where the deep copy aspect becomes really important. Understanding the implications of mutability is critical in this statement. This line refers to the function from the scikit-learn library that's central to the quiz. It's the tool we use to make copies of machine learning models. Think of it like a photocopier, but for models. Let's explore how well this photocopier makes copies. The core question sets the stage. We're evaluating various claims about how Sklearn, base, clone behaves. It's like a multiple-choice question testing our understanding of this cloning function. Ready to tackle the statements? This is the result of using Sklearn, base, clone on the original model. It's a new copy, and the quiz tests whether changes to this copy will affect the original. Let's see if they're truly independent. This is our starting point, the original scikit-learn model. We want to understand if cloning it creates a truly independent copy. The key is to see if any modifications to its clone will affect it. This question asks about the behavior of Sklearn, base, clone which is a function from scikit-learn's base module. It's used to create copies of machine learning models. The key here is understanding whether these copies are truly independent of the original or if changes to the copy affect the original model. The quiz tests your knowledge of how Sklearn, base, clone handles deep versus shallow copies, especially concerning mutable objects like lists or dictionaries. Statement A claims that Sklearn base clone always creates a deep copy. A deep copy means that a completely new, separate copy of the model is made. Changes to the copy won't affect the original. While the function aims for this, it's not always guaranteed, especially if the model has complex, nested structures. Statement B is mostly correct. The main goal of Sklearn base clone is to provide independent copies, so changing a parameter in a clone shouldn't touch the original model. Statement D is false. If the original model has mutable attributes, like lists, changing those within a clone will affect the original model because Sklearn base clone doesn't guarantee a deep copy for all attributes. Statement C is also false. Sklearn base clone isn't limited to models with a fit method. It works on a wider range of scikit-learn estimators. This question sets the stage. It's asking us to consider how the Sklearn base clone function in the scikit-learn library behaves when creating copies of machine learning models. The key is to understand whether modifications to these copies will unexpectedly change the original model, model_a. Statement A claims that Sklearn base clone makes a perfect deep copy. A deep copy means creating a completely separate, independent copy of every single piece of the original model. This would ensure any changes to the copy won't touch the original. We'll need to explore if this statement is entirely accurate. Statement B focuses on whether adjusting settings, parameters, in the copied model will accidentally change model_a. This is the core functionality we want from cloning: separate copies with independent modifications. Statement C suggests a limitation. It claims Sklearn base clone only works with models having a fit method, used for training. We need to verify if this is a true restriction or not. Statement D delves into a more complex aspect. Mutable objects, like Python lists, can change after creation. The statement asks if modifying such objects within the cloned model will also alter the original. This tests our understanding of deep copying and mutability in programming. Hey Vamsi, this line introduces the topic. We're diving into how scikit-learn, a popular Python library for machine learning, handles creating copies of models using the Sklearn base clone function. It sets the stage for understanding how cloning works within the context of the quiz question. This is the core question of the quiz, Vamsi. It's asking us to evaluate multiple statements about the behavior of Sklearn base clone . Each subsequent line presents a statement for us to analyze. This statement claims that changing something in the copied model won't change the original. This is crucial for understanding if Sklearn base clone truly creates independent copies, which is the main idea of this quiz question. This one suggests a limitation. Sklearn base clone might only work with models having a specific fit method, a function used for training the model. We have to check if that's true. This statement discusses the impact of changing mutable objects, like lists or dictionaries, inside a cloned model. It tests our understanding of deep versus shallow copying within the Sklearn base clone function's context. This question is asking you to identify correct statements about the Sklearn base clone function in scikit-learn, a popular Python library for machine learning. It focuses on how Sklearn base clone handles creating copies of machine learning models. Understanding this is crucial for building reliable and independent model variations. This statement explores the behavior of Sklearn base clone when dealing with mutable objects. Objects whose values can be changed after they're created, like lists or dictionaries. The statement claims that if you modify a mutable object within a cloned model, the original model won't be affected. However, this isn't necessarily true. Sklearn. Base. Clone aims for a deep copy, but with mutable objects, it might not completely achieve it. So modifying a mutable object inside the clone could change the original model's mutable object also. Think of it like this. If you have two identical boxes of Legos, your model and its clone, and you remove a piece from one box, the other box will remain unaffected only if you have completely separate sets. If both boxes share some bricks, taking one from one will also reduce the other. This describes the overall topic, understanding how scikit-learn's "clone" function works. Scikit-learn Sklearn is a very useful tool for machine learning. The "clone" function, specifically from the Sklearn base module, allows you to create independent copies of machine learning models. This is essential when you need to make changes to a model without impacting the original. Here, model _a is simply a placeholder for the original scikit-learn model. It's the model that will be cloned. Think of model _a as your original recipe. You can create many copies, clones, and modify them, adding different spices, but the original recipe remains unchanged unless you actively modify it.